Greetings! I will first explain how to use the missile and then how it works. To use this missile, you want something that can be put on a navigation table to track an objective. In this case, this compass right here, you see, tracking that over there. You get back here, you place one right there. You get back here, you place one. And over here, you place the last one in this hopper. Missile now knows where it is. Then you get down here. There's these dispensers. You want 21 TNT on each of those. It can be less if you want, or even none. But what this is gonna do is it's gonna increase the yield of the missile when it detects a target, because this is a clock back here. It's gonna spam TNT when it gets to the target. Also, if you do not place any TNT on any of these things, there is a chance that the missile will hit the ground. This TNT is gonna light, fly off because it glitched or whatever, and you have a dot. You do not want that to happen. Now, very important, extremely important. I'm gonna draw an angle back here. See that angle right there, 128 degrees? Do not have your objective in that angle. If you do, you're gonna be in trouble because the missile is gonna get confused and it's gonna crash. Let me elaborate on that. So we have our objective over there, and we're gonna start rotating this. Eyes on these repeaters right there. Start turning. Like back here so you can get a better look at it. Keep turning. It triggers. The missile would then crash and you lost your missile. Do not fly it within 128 degrees aft of your objective. So for example, this one right here, it takes off and it goes over there and it hits the target. If you put it over here, when it does a turn, because the target is more to our right, it's gonna enter that 128 degrees and it's gonna crash. Now, this back here, this lever is gonna actually, make the missile go. So if I trigger this lever, it immediately starts moving. Well, it's in reverse because again, it's within the angle. You obviously want to put fuel into these portable engines right here. You do not need this many. I didn't know you could supercharge them. If you want to supercharge them, then go for it. Just supercharge this and remove the others. I don't know, it should work, probably. And well, launching them, you can just place them vertically like this. You just release it. In this case, I have this here hooked up to a receiver, hooked up to this lever. You flick that lever and it just takes off. Or you can even have them horizontally like this, and it will, it will take off and start climbing. Thrust to weight on these missiles is pretty insane, so you should be fine when it comes to launching them. That's basically it when it comes to using them. I will now explain how it works for those who are interested in that. Okay, so the basics of this is gonna be an automatic sort of like leveling, flight control. It's gonna make this thing climb and go on a straight line. So we have these sensors here. So this is gonna be correcting here laterally. So it's gonna be like if it starts rolling to one side, we're gonna take this. Look at this comparator here. Tries to roll the other way. Look at this one there. There it goes. You see that in the middle, neither of them are activated, so that's gonna be level flight. Similarly, well, not really similar, this is different. We have a comparator here that's gonna be set up by an analog lever to cut off the signal once it gets to a certain pitch. So right now it's trying to climb up. I'm gonna grab this here, we're gonna start pulling up. You're gonna see it stops right there and this propeller turns off. If we pitch down, starts right back up. So I'm gonna demonstrate it here by we're gonna enable the missile and we're gonna release it, and it's gonna immediately start climbing. That's gonna go all the way to the cruising altitude up there. So I'm gonna disable the navigation again. Now that's gonna be the basics of how this thing maintains level flight. Now for our first section of control, so to speak, we're gonna have what I call the initial guidance, which as the name implies is gonna be the initial thing that it does. So if we have an enormous error, like here, look at that angle, man, like 90 degrees, it's gonna tell this down here to send a signal up there to disable something that we're gonna explain, and it's gonna every few often tell the missile to roll this way. So it's gonna roll this way, it's gonna force it to start turning towards the objective. The signal that we sent up here to disable was this one. This is basically telling this comparator to activate and send a signal to this comparator, which is the one that's actually telling the ailerons how to behave. It's gonna tell them that level flight is no longer this, it's actually this. So it's gonna be locked into that. Well, actually that's a little bit too much. Look at the comparator. There we go. It's gonna be at this angle, it's gonna do a gentle turn. If you do more, like if you increase the analog strength here, it's gonna, try turning more and more steeply, but then when it stops turning and it corrects, that's gonna make an enormous yaw to the other side. It's gonna be a nightmare to counter, so keep it nice and gentle. Okay, so now we made it slightly later so we can see these lights better. This is important. We are turning, and then we enter the fine control area. This means that the error in our direction of motion is no longer that big to necessitate a wide sweeping turn. So this is going to a controller here, which I did not make myself. Let me look up the name again. Hold on. Mysda on YouTube made this controller. It's like a PD controller but more stupid. I'm gonna link the video in the description because it's really smart in what it does. I like to call it a pulse weight add controller, because what it's gonna do is that if there is a small error, it pulses this. It slightly turns this way. It waits. If the error is corrected, no problem. If the error is not corrected, then that means that the error is bigger. So it just goes full swing. I'm gonna demonstrate that. So we go this way. It starts correcting. Then it's gonna stop, waits, and then it's gonna activate again. That what it does is that it prevents that feedback loop of like correct this way. Oh, sorry. It corrects this way, it stops that from happening. It's gonna ensure that we have a fine peak to go through our error correction instead of just entering a loop. And this is gonna take us all the way to the objective. The error by the end of this flight to the objective is gonna be like a few meters at most. So this is a really good controller, and again, thank you so much for the design to Mysda on YouTube. Now, the way this is activated is that this gravel here is sending a signal to this comparator to turn off. That's gonna stop it from overloading the controller while it's not actually in fine-tuning mode. Because if you just let it go, it's gonna start overloading this what the hell was this called? Condenser? Inductor. Yeah, the inductor is gonna overload, it's gonna accumulate value, think that the error is enormous, and it's gonna fuck up the controller when it's actually getting into fine tuning. So that's like a little thing I have there to prevent that from happening. Okay, so now we are directly over the target, and that's because I'm about to explain how this thing actually hits the target. So the main thing is this navigation table. Remember that the compass goes in here or something to track the target, which I forgot. Thank God I checked that shit. This is basically gonna wait until we fly past the target, then gonna send a signal here. This is an analog lever. Is what determines. Remember, the 128 degrees is gonna diminish if I increase the strength of this, but that's also gonna increase the error because it's gonna be more of a tight margin for when it detects the thing below it. So I have it as like a compromise of 5. You can mess around with this and just see what happens. This is gonna send a signal to this link up here, and what this is gonna do is that it's basically gonna reverse the engine, and it's then going to wait until we fly past the objective again. So we're gonna go over here, fly past it, reverse, and when we pass it again, it's then gonna send the signal to the side over here. So we're gonna demonstrate that. Look at this. We're flying past, keep going. There it goes. The engine reverses, and it's just gonna keep doing that. It's gonna keep reversing, and we're gonna fly it past here. And now it's gonna start going forward. Why is that? It's because back here there is another inductor. It's gonna count how much time it was reversing for, and it's gonna cancel out that velocity with a little forward pulse of the engine. That's so that we don't end up flying all the way backwards. We go forward, detect the objective, fly backwards, cancel out the momentum, and then hit it. And the way we're gonna hit it is that we're gonna have a little compass, and this compass is gonna be our final navigation mode. So if our target, we're gonna move this a little bit back, is below us, it's gonna send a signal to the control surface to pitch down. And if it's above us, it's gonna send a signal to the control surface and this propeller, to turn as quickly as possible to pitch up. We're gonna pitch down, keep going, pitch up, down, up. And that's gonna keep going all the way until we hit the objective. That's basically our terminal guidance right there. Now, for the last thing, once we are finally at the ground, there's gonna be this little thing back here, and it's gonna send a signal to here. This is, by the way, this little link here is connected to this so that the missile cannot actually explode from the optical sensor when it's not activated. It's gonna activate this rose quartz lamp that is going to, one, ignite this TNT, and two, is gonna enable this clock here to just start going ham on the dispensers, and that's gonna spam all the TNT on them to maximize the explosion radius. And once that happens, the missile is gonna blow up. So I'm gonna demonstrate that now. I almost forgot to say really quickly. This, when it triggers this side, is gonna send a pulse here to make the propeller to run for a second. It's gonna pitch the plane down so that, you know, by the end of when the reverse is over and we're correcting forwards for the final grand slam down there, we are actually, you know, aiming down instead of like aiming like this or up or whatever. So now for the terminal guidance, we're gonna take this and we're gonna release it. Release it. There it goes. And it hits. And it starts spamming TNT, and now this is gonna explode. There you go. Look at that lag. So yeah, that's basically it. Thank you for watching.